Welcome to Brain Vision.
A 240 VRMS 60 Hz supply serves a load that is 10 kilowatt resistive and 15 kilo VAR that is capacitive and 22 kVAR which is inductive. Find first the apparent power, second the current drawn from the supply, C kVAR rating, and the capacitance required to improve the power factor to 0.96 lagging, and D part is the current drawn from supply under new power factor conditions. For the first part, calculating the value for apparent power, which is equals to 10 into 10 raised to the power 3 minus J15 into 10 raised to the power 3 plus J22 into 10 raised to the power 3. This is equals to 10 plus J7 kVA. This becomes our first equation. Calculating magnitude of apparent power, which is equals to under root of 10 into 10 raised to the power 3 whole square plus 7 into 10 raised to the power 3 whole square, and the value for the magnitude 12.21 kilovolt ampere. This is the apparent power. For B part, the current drawn is equals to S by V. Substituting the value 10 plus J7 by voltage is 240. This is equals to 41.67 plus J 29.167 ampere, and the current drawn will be equals to the conjugate of I conjugate, which is 41.67 minus J 29.167 ampere, and the converted form will be 50.86 angle minus 35 degree ampere. This is the current drawn from the supply. For the third part, theta 1 is equals to tan inverse of Q by P. This is equals tan inverse of 7 into 10 raised to the power 3 by 10 into 10 raised to the power 3. From here, the value for theta 1 is 35 degrees. Considering the new power factor, then cos theta equals 0.96. From here, the value for theta 2 will be equals to 16.26 degrees. Now, the calculating reduction in the reactive power caused Q1 minus Q2, which is equals to P tan theta 1 minus tan theta 2 equals to 10 into 10 raised to the power 3 into tan of 35 degree minus tan of 16.26 degrees, and the value for the reactive power is 4.083 kilo VAR. Calculating the value for capacitance. Capacitance is equals to QC by omega VRMS square. Substitute the values 4.083 into 10 raised to the power 3 divide 2 pi into 60 into 240 square equals 188.03 microfarad is the value for capacitance. The next part is S1 equals P1 plus JQ1. From here, P1 equals 10 kilowatt and Q1 equals Q minus QC. Substituting the value, here Q1 value comes out to be 2.917 kilo VAR and S1 equals 10 plus J 2.917 kVA. Now calculating the current drawn from the supply, I1 conjugate is S1 by V. Substitute the values. We have I1 conjugate is 41.67 plus J 12.15 ampere, and the current drawn will be the conjugate of the I conjugate, which is equals to 43.4 angle minus 16.26 degree ampere.